many are, like we are seeing what, like, many road accidents. And in fact, why government of India, had a strict rule for having helmet is, not to prevent head injury. Okay, so head injury, brain, whatever the insults, okay, insults or injury that, the brain is experienced, then most of the time it is irreversible. Okay, something happens to brain, most of the time it is irreversible. Okay, and there are some cases, if you see, maybe 5 to 10%. But even for those cases, doctors, if you see, most of the time they don't have any clue on, okay, why that particular medicine they're working for the patients. Okay, the same medicine, okay, the same condition, different patient. In one case it works. In another case it doesn't work. So that's a different story. Brain related. And even in our hometown and all, something if you see somebody injured brain, having brain injury, uh, I mean they say, yeah, it's a severe damage and very tough to survive, all those things. It's all about brain disease, by the way, so here, okay, in this course, we are not going to talk about heart, okay, cardiovascular system. We are also not going to talk about brain related system. We are going to talk about muscles. Okay, muscles. I'm pretty sure that, you might not have heard much about muscles. Okay, so whenever we say muscles, okay, we refer to skeletal muscles. So what are the functions of muscles? Why we have to study this? First of all, let me just think. Let me explore the functions of muscles. What are the functions of muscles? Anybody can contraction, relaxation, then elasticity, then good, correct. Then sorry, ma, support for movements. Okay, great. Then is there any? Okay, right. See, muscles. If you see, if you consider our human body, there are more than 600 plus muscles. Okay, for example, I'm talking with you. Okay, what, see my face, my facial muscles. Okay, should coordinate with my brain in order to just have correct pronunciation. For example, see, whatever I'm thinking, okay, with no time, I could able to produce without any difficulty. Okay, thanks to muscles. Facial muscles. See, in face itself, we have 40 plus muscles. Very small muscles. For example, your eye, eyebrows, right? We can just you see this smallest muscle, what we have in our human body. Again, think about, if you're not able to just blink your eyes, open your eyes, then the life is pretty, okay. Then movement is life is movement. Okay, you can just try this experiment. Okay, if you, we are all nowadays, if you see the sedentary lifestyle. Okay, many are sitting in front of computer, and even playing. I see students they are just using mobile phone, and they are just doing some they are using some what, app for this thing. They're not for example, in our time, if you see we can see play, what students in ground, okay, and they were playing. But here nowadays, everything, if you see because of the technology or whatever, we are not this thing. So movement is another one important and then it's not about, again, movement, I don't want to just uh, take it lightly. For example, let's say for example, see, I want to just take this. Okay, this object. Okay, see, without any difficulty I can able to take it, right? No, again, see, I cannot only give my this thing to, what, full credit to muscles. Okay, my brain is also involved. Apart from that, a lot of sensors are also involved. Okay, but anyway, see, if I want to just lift this object, okay, without any drift, okay, then obviously like what, like the precise force that are required to lift it to be generated, which is generated by muscles. Okay, and again, like this is not, I mean, this is fine if you want, if you are writing right now, writing like for example, you cannot, let's say, fine, if we ask you to come up with the, I mean, a robo like that like can write, it takes lots and lots of time, and that same robo, if you see, cannot just take a glass of water or like what, like without crushing the bottom. Again, like for that, like you have to bring another level of intelligence. Okay, so I mean, muscles, as I said, movement means everything. Okay, starting from like writing, talking, walking, okay, everything. Okay, and then another one important function, or let's say responsibility of muscles, is posture maintenance. You are all sitting like with no, I mean, with comfortable, I mean, you are just comfortably sitting. If you see, if you ask your parents, they say that no, I cannot sit, like I have I mean, back pain and so on. And if you ask somebody like who has some sort of injury on their knees, they also experience some sort of discomfort in knees. Maintaining posture is another one important functionality of muscles. For example, I mean, we are also working in this problem. See, we are using computers, we are using mobile phones. Okay, and let's say when you are watching movie, or when you are in meeting, okay, sometimes like we cannot just we will not pay much attention to our posture. Okay, that actually results in some sort of deterioration on neck muscles. Yeah, neck muscles are another one, this thing. For example, if you see the weight of this thing, I mean our head, it what would be the weight, any idea of our head? What would be weight of our head? Some 5 kgs. The muscle, it that like withstands, I mean, that holds the entire weight. If you see, there are only, I mean, I think some 2-3 muscles are there, trapezius, and then some other I mean this thing, I mean, associated muscles. If you see in terms of weight, that will be very minimal. But like these muscles like hold your head such that like you can like comfortably like what, like watch movies, or I mean participate in the meetings and so on. Again, like muscles plays a role in like maintaining a movement. Okay, in fact, the science that deals with posture is called as posture, and workplace design is called as ergonomics. Okay, this is one of the, again, the science that deals with movements, mechanics, I mean mechanics related to movements, technology. Again, for example, like if somebody is like, I mean, when I talk about movement, then obviously we can talk about amputees. Amputees could be due to several reasons, right? No, I mean, one very well known common this thing reason is what? Road accidents. We see, for example, like I mean, in the morning we had Dr. Kumaravel sir, right? He is one of the famous orthopedic surgeon. Okay, whenever like we attend his, I mean, whenever like we visit his office, we see like I mean, at least 2-3 patients without limb. Okay, with I mean like stick. Again, the discipline that deals with okay, I mean like this kind of like I mean patients with amputations, and the technology that like I mean we researchers like work to enable them to walk. It's called rehabilitation. Okay, all if you see starts from muscles. Again, muscles, if you see in our limb, uh, I mean we have some I mean prominent muscles. Okay, quadriceps and hamstring and so on. Okay, by the way, so these are like some of the functionalities of muscles: verbal communication, posture maintenance, right? No, walking. These are like some of the this thing. Okay, functionalities of muscles. So this course deals with I mean understanding, okay, of what are the fundamental units of muscles. Number one, what would be the muscle functions when, I mean muscle functions, let's say for like normal patients, I mean sorry, normal people, and then patients. Number 2, how do you measure the muscle activity? Number 3, where and all this muscle activities can be used. Number 4. Okay, again this could be achieved in different aspects. That's why the first one, if you see, we want to teach modeling as well. How do we model the signals and so on? Okay, that will be taught by our foreign faculty. And the measurements, as I said, most of the time we will be interested in surface EMG signals. So in this class, I'll discuss about the fundamental unit of muscle. Okay, we know about muscle. Okay, as I said, we have 600 plus muscles in our human body, helps in movement, responsible for movement, 4 generation, as I said, and then verbal communication and so on. Now we want to see what are all the components, okay, present in the muscle. Okay, and then how do you measure it? Okay, these 2 things will next part. Yeah, so next. So yeah, before that, again, this is for general audience. So signals, what we mean by signals, generally you would have known. By the way, anybody can help me? What do you mean by signal? Yeah, physical quantity conveys some information, right? No, here we are going to deal with biomedical signal or here physical quantity, same physical quantity we measure, but it conveys information about the underlying organs or tissues. We'll be going to study about sensors, okay, okay, called electrodes. We'll see how it works. So we'll see what happens when you place electrodes on the muscle, let's say. Okay, what sort of signal you will get? For example, as I said, an ECG is one of the excellent example. Okay, you need not have to just do intra, open the heart and you can see how the heart functions. From ECG itself, most of the time we'll come to know whether the heart is functioning normally or abnormal. Okay, so as I said, biosignals, okay, it carries information about physiological mechanisms of living system. Okay, so let me start with this thing. By the way, see, the idea is, I want to discuss about muscle, the components present in the muscle, okay, and then generally signals we use to measure the muscle function. So I thought that I can give a brief intro about signals as well. Okay, you can see the first ECG machine. We want to show the development or growth that we have through last a few years. You can see the growth. Okay, if you see in early 19th century, okay, the ECG machine what we had, and you can see now what we have. Okay, you might have heard about smartwatches. You will get it for some 65,000. Very good smartwatch, it captures your cardiac potentials. Okay, so this is the development of technology. Even in most of the clinical centers you can find this system. Okay, this is, by the way, validated. Okay, doctors usually utilize this, and this is again wearable ECG electrodes. Okay, where as I said, we have smartwatches, it gives information about cardiac potentials. Okay, so these are all different signals. Okay, we have EEG. By the way, this is for your understanding. Okay, we have signals, biomedical signals gives information about physiological system. Again, if you get signals from brain, you can see this. Okay, a poor kid, they measure EEG. They placed electrodes, over their head. He said, it looks like this. Okay, it looks like this. EEG, electroencephalogram. Okay. Similarly, when we place electrodes on the chest, we'll get ECG, EMG. EMG is what we are interested in. Okay, electromyography. Okay, electro means electrical activity, myo means muscle, graph means just one 2D picture that shows the temporal variation of the signal. Okay, we'll be more interested in EMG. Apart from that, these are some of the measures. ERG, for example, like if you want to know if you want to assess the eye functions, let's say ERG we use, and EOG, eye movement. Okay, we use EOG. Okay, so these are some new this thing. I mean, biomagnetic signal. We have MEG. It is not. I think in India, like we have a few places. I think only 3 or 4 places we have MEG. The system itself, like I mean, like if you see the cost of the system MEG, this itself comes in terms of crores. Okay, MEG and biochemical signal, like you might have heard about this thing. Okay, no, I'm not responsible. Okay, so these are all different types of signals. Okay. That's it. இப்போ ஓகேவா? We project it pa. So how many of you worked in signals? How many of you know about I mean, sorry, how many of you at least know about signals? என்னாச்சு? So what actually we will have, I mean every day afternoon, okay, we are planning to have tutorial sessions where like you'll be given signals and you will be asked to do some small tasks, okay. And as Professor DK said, we have already separated in terms of groups right now. I think most probably it will be teamwork. So we want you to just know, I mean, understand the let's say the basic let's say steps involved, and by the time by the time you leave, you should be in a position of like conducting research, some sort of like I mean some sort of basic research in medical signals. That's our that is one of our this thing. Okay, yeah. So yeah, this is fine, right? No, biochemical signals, you might have known about it. uh, So similarly, bioacoustic signals, we have biomechanical signals, bioimpedance signals, which means what actually I would like to say is like it's not only, I mean, not only electrical signals that we can extract. Apart from that, we can also extract mechanical signals, magnetic signals, optical signals. Okay, from I mean human body, and that can be used for either diagnosis number one or prognosis and so on. Okay. So I mean, if you see, these are all the I mean possible sites. Okay, if you take human body, okay, if you see, and most of the measures, if you see, most of the measures are non-invasive technique. What we mean by non-invasive technique now? I mean non-invasive technique means, uh, I mean, you need not have to like let's say for example like injection. Okay, injection is one of the I mean invasive approach. Okay, we have to puncture the skin and we just insert the needle. Here we see whatever the techniques we have mentioned, all are like non-invasive, which means like we place the sensor outside the body and we just I mean extract the information. Okay, yeah. So now we are coming to the course. So I mean with this introduction, now we'll start looking at looking at a narrow level. Okay, if you see either brain, if you take brain, I mean yeah, if you take brain, if you see, we have about 100 billion neurons, more than that maybe. Okay, And again, what are the functions of brain? Anybody can help me? Brain, yes. Decision, movement coordination, great. Just room number 21 pa. Room number 20. ஏதோ வேணும் பாரு வேற பக்கம் கேட்டு பாரு நீ சதீஷ்ட கேள கிளாஸ்ல இருக்கேன்ல சரி சரி நீ போயிட்டு அவரு கூட யா கிரேட் தென் வாட் எல்ஸ் speech language comprehension okay then hearing cognitive is there anything else remaining communication yeah so brain is a complex machine okay it's a masterpiece of our human body okay it involves in almost all the process you cannot identify a single let's say activity without brain's involvement you cannot say sir if you see this activity I'm not using brain okay you cannot deal in it for example like you cannot uh, let's say deal in the sense like let's say like if you take any act any daily activity let's say brushing you cannot like what deal in it okay you cannot do it right no so it involves in everything okay it involves in everything so why why I'm talking about this so this workshop is about muscle why are talking about brain see brain controls muscles okay brain controls I can tell yeah through spinal cord okay brain so with that knowledge as I said like we have about 100 plus 100 billion neurons right now we'll see at a neuronal level and we will see how these neurons communicate with muscle okay because whatever the measurements what we do whatever the measurements we are planning to do on muscle okay is also directly or indirectly contains information about brain involvement you got my point so that's an idea so you can see this we have three different types of neurons pa okay neurons you can see this is motor neuron okay motor neuron generally motor neuron originates from the motor cortex okay brain let's say yeah top region of the brain and like it just what like it originates from top region and then like it just comes down okay uh, to spinal cord okay this is motor neuron okay so signals sent to your muscles to tell them to move or not to move and so on okay so this is fine and then the second thing yeah this second this thing type is sensory neuron what we mean by sensory neuron for example somebody is like let's say touching us or like let's say if I'm just lifting this okay see if I say this if I just I'm lifting this you can see several things okay see while I lift I didn't crush this okay which means the force applied by my hand is exactly equal to the force required to lift this without crushing right no so how it happens how brain we are talking about brain controls muscles brain how muscles like generates the exact force that are required to lift this thing lift this object see it does so because we have sensory I mean, sensors, let's say, yeah, touch sensors. Okay. Generally, the moment I touch this object, this sensory neurons will be activated. Generally, this sensory neurons start from here and it goes all the way to brain. See, this is what happening. Here, see, starts from sense organ, okay, then it goes, up, by the way. So, I mean, this is how this thing, I mean, sensory neuron works. Uh, I mean, apart from this motor neuron and sensory neuron, we have interneuron. Interneuron is something like it connects this sensory and motor to motor, sensory and sensory. So just that's a neuron, it stands somewhere in between. That's it. Okay. So now we come to our topic. See, again, coming to the same example. See, I mean, when I live this, okay, I mean, when I try to live this, I could able to do it without any drifting or without any difficulty. And all this, I mean, as I said, we have sensory neurons. Okay, this gives some information, and at the same time, I look this object, right? I look this object. Then, the moment I look this object, okay, what actually my brain should, I mean, basically, we have our eyes, right? Eyes have seen the object. Then, what happens? Just it gives information about the object, shape, texture, and so on. Then, what information we'll get? I mean, what is the, I mean, how much distance, this particular object is there. Okay, all those things will be given by our visual system. Okay, brain, I mean, generally, our eyes generally, gives all this information to, motor, I mean, region called motor cortex. Okay, this, with this information as well as the information, when we try to, I mean, the moment we touch, the texture information, all this information, now, brain, decides this much force is sufficient, and okay, this thing. So this is a basic, mechanism of movement. Again, if you consider the brain, we have the cell body. Okay, these are all dendrites. Okay, generally the signal, I mean, we have dendrites, cell body, and then axon, and then this is axon terminal. Generally, see, when the brain, I mean, the neuron is stimulated, just know it will be, I mean, this part, this dendrites part is usually connected to another neuron. You can see this here we have. See, this is neuron, this is one neuron, this is another neuron, this is another neuron. If you consider this is the head of the neuron. See, this is head. This is connected to tail of another neuron. Okay, again, this is connected to the tail of this neuron is connected to head of this neuron. Okay, we call it as this fellow as presynaptic and this fellow as postsynaptic. Okay, yeah. So this is all about brain and and their functions and other things. You can see again when we say muscle, as I said, I mean, sorry, I didn't say. So there are three different types of muscles. Okay, cardiac. I mean, the heart. It's a muscle again. Okay, and our intestine. Stomach. Okay, I mean, that is another muscle, and skeletal muscle. Okay, one clear, I mean, difference between these three types of muscles. See, cardiac muscle, it does not need any excitation or stimulus. Okay, it need not have to ask us to whether to beat it or not. Okay, it will not ask, right? No. Similarly, intestine muscles, stomach muscles. Okay, intestines, large intestine. In the intestine, we have small intestine and your bladder. Okay, bladders. Yeah, that also. Okay, these are also does not require any input from us. Okay, so which means we don't have any control. Okay, these are all that's and skeletal muscle. Okay, as I said, we have about 600 plus muscles in our human body. Okay, that is actually that needs some input from us. Okay, so what we call it as these are like excitable muscle fibers. Okay, excitable muscle fibers, because it needs some sort of excitation from our side. Okay. Uh, yeah, I mean, whatever I explained. So we have 600 plus muscles. You can see uh, it primarily contraction and extension, but I mean functions will not, will not simply term in terms of contraction and extension. Okay, you can see these are some of the functions, okay, of muscles. Okay, the properties, again, excitability. Muscle, if you give stimulus, it responds. For example, when we have a thought to move, you can do it. But for example, we cannot increase our heart beats when you think. But muscle, it's not like that. I can just, if I want to do curls, I can do a number of curls. I mean, nobody can ask me. Okay. So that's it. Excitability, contraction. You can see this is contraction. The angle between, let's say, this is one body segment and this is another body segment. The angle between this body segment reduces. Then it means there will be a contraction, and then the angle increases, extension. And another one important property is elasticity. Yeah, so this fine muscles. I mean, if you again further narrow down from muscle, if you see, you can see number of motor units. Okay, very small. I mean, muscles, one muscle. If you see, if you look at a muscle, will have, the fundamental unit of muscle is motor unit. Okay, generally I'll tell you, I'll just give two very nice example. Okay, I mean, we can stand right now. We can stand for even 2 hours, 3 hours right now without much difficulty, because if you see our thigh muscles, you know, uh, I mean, thigh muscles. If you see, lot of motor units. Again, what we call it as lot of slow twitch motor units. Okay, I'll tell what we mean by slow twitch motor units. Okay, so I mean, we have as I said, you can see more than 500 motor units in limb. Okay, lower limb. Okay, you can stand for a long time, and there are also muscle with very low number of motor units. As I said, this thing, the muscles involved in blinking the eyes. I think very few. Okay, very few. Okay, you can refer it. Okay, so yeah, so this is fine. Yeah, so this is the process I was explaining. Okay, I want everyone should know about this. Okay, you can see whatever I explained so far, I mean, you can see here. See here, the process is this. I mean, see, I mean, we want to see whether I mean, we are opening the tab and we want to see whether we are getting I mean, cold water or hot water. Okay, if you see how the network works. Okay, and by the way, I mean, the moment if you see, let's say if you are getting, I mean, if you are seeing a hot water, the moment we can just know, I mean, take our hand outside, right? No, so I mean, you can see, which means, okay, all these things happens with no time. Okay, no time in the sense, I didn't mean literally 0 seconds, maybe in terms of micro or nano, whatever. Okay, and if you see the process, you can see this. We have I want to see the this thing. I mean, this the green vessel. Okay, these are our touch sensor. Okay, see, this is sensory endings in the skin. Okay, it takes the information to the spinal cord. Okay, and I mean, sorry, it just it takes, yeah, through spinal cord to brain. Okay, to brain. Immediately brain understands the signal and it just know. I mean, see, you can see that, see, this is yeah, you can just know, I can go with the this thing. I mean, see, you can see this is sensory endings in skin. Okay, then if you follow, see here it ends. Okay, this neuron, we discussed about neuron right now. We discussed about neuron. Okay, here it ends. Again we have another neuron. Okay, you can see this. This is interneuron. Then we have another neuron. Okay, see this is the neuron in the brain. See this is brain. Okay, okay. So this neuron, okay, gives, I mean, gives the information about whether, like, what we have, okay, at our hand, whether is it cold water or hot water. Then accordingly, you can see, like, another neuron will be activated. Okay, there will be some decision will be taken, and, like, it comes from brain to directly this is spine cord, and then it acts to this thing. I mean, so these are, like, what I mean, what we call it as, this will be connected to some muscle, then only, like, you can move it. Okay, without muscle involvement you cannot move it. Okay, without muscle involvement we cannot move it. So yeah, so this is the, the flow. Okay, so all this thing happens with, very less time. Okay, okay, you can see this. Okay, so this is the right side, and the left side. Generally, like, there is a say, I mean, generally right part of the body controls by left side of the brain, because, like, there is a diffusion. Okay, I mean, generally, yeah, but anyway, that is not required here for you. And right controls left. Okay, so yeah, so this is what we are, studying. I mean, I was discussing so far. Okay, you can see that. Uh, okay, see, this is same task in all case. Okay, we are primarily interested in, okay, drinking water, and I am taking a glass of water, but glass, if you see, in one case it's a plastic. Okay, okay, you can see, like, in three cases, okay, everything, like, this thing different. Okay, in one case you can see that it's a plastic, and if you see this is glass again, like, if something bad, like, it will fall down into this thing. So we can able to do conveniently, because, like, your brain, okay, generates the exact force, to complete this task. Okay, so yeah, I mean, we maybe, like, we will explain about the other terms. Okay, so yeah, so it's fine, right? No, we you can see the motor units. Okay, as I said, it's the brain's smallest fundamental unit of force development and control. Okay, these are all motor units. You can see this. I mean, this is muscle. Okay, this is motor unit, this is muscle fiber. Okay, so every muscle contain n number of motor units, and each motor units contain muscle fibers. Okay, each, right, no, yeah, each motor units contains, muscle fibers. You can also see, I mean, this picture and this picture same, but this picture gives clear, idea. You can see this is one motor unit, this is another motor unit, and each motor unit is controlled by, one, motor neuron. Now you think about it. So we have how many muscles, and we have 600 plus muscles, and each muscle can contain, like, even, like, we have seen there are some muscles with 500 motor units, and each motor unit need one nerve, I mean, one, alpha motor neuron. Then you think about, like, how many motor neurons we have in our human body, like, with this thing, I mean, like, for us to perform all our, daily activity. If something goes bad, most of the time we don't know, like, why, I mean, why we are getting some pain, or why particular medicine is working, why particular medicine is not working, because of these issues. Okay, okay, so yeah, so it's fine right now. I mean, muscles, the fundamental unit of muscle is motor unit. Motor unit contains muscle fibers. Okay, this is what, like, I want to this thing, and we have two different types of motor units. Okay, I want this thing, I mean, this to be known. uh, what are the two different types, how it helps us, another time acha. Okay, see, So we have two, I mean, as I said, like, we have two different types of motor units right now. So so many of you would have seen, sprinters, right? No, or marathon runners, right? No, have you seen? Have you discussed? Any of you here, like, any runners, athletes, sprinters, marathon runners? Nobody's nobody's athlete. Yeah. Okay, fine. So. mm, So this, I mean, we have two different types of motor units. The first one is slow twitch muscle fibers. Okay, very simple. Motor units contain muscle fibers, and this muscle fibers, based on the diameter of muscle fiber, and then the four generation, uh, this motor units are categorized into two different types: slow twitch, fast twitch. Slow twitch means muscle fibers with uh, a small diameter, okay, and it generates small force, okay. Generally, if you see marathon, if you see marathon runners, okay, they target, okay, to enhance their slow twitch muscles, because slow twitch muscles gives low force for a long time, okay. And fast runners, athletes, sprinters, they, like, try to enhance their fast twitch muscle fibers. If you see fast twitch muscle, the diameter of fast twitch muscle fibers, the diameter is comparatively larger than slow twitch. They get large force in a short time. So that's this thing. So even there are some studies now, they said that, like, uh, the slow twitch muscle fibers can be transformed to fast twitch muscle fibers. Okay. So I mean, this is what, like, so we have two different types. Broadly we categorize into two different types: slow twitch and fast twitch. But there are some, studies, like, there are some cases, like, they categorize fast twitch into further to this thing. Case fast twitch type 2A and type 2B. You can see that, but, like, mostly, okay. This is all about slow twitch and fast twitch muscle fibers. Okay. Okay, you can see this. Yeah, so this is very nice study. You can see here, this is, EDL, okay. You can see this fast twitch fiber, EDL, and slow twitch fiber, solusus. Okay, solusus is nothing but our this thing, our lower limb muscle. Okay, you can see this. See, if you look at this two pictures, graphs. In one case, peak force generated by this EDL muscle is larger, which means this is fast twitch, and solusus is slow twitch. You can see this here. See the peak force and then time. If you see, it gives about it generates about 500 millinewton. It lasts for only, let's say, for some 50 milliseconds. Whereas if you see the other case, peak force is about 330 millinewton, but it lasts for about 150 milliseconds. That's what I was telling. Like, so slow twitch generates low force but lasts for, like, longer time than the fast twitch. Okay, that's what, like, generally, like, now the surface EMG signals plays a huge role in sports mechanics to improve their performance. For example, as I said, athletes, if they selectively, like, concentrate on, like, fast twitch muscle fibers, they can enhance their muscle fibers and then they can improve their performance. Okay, that's what, like, nowadays, like, they use EMG and they use IMU, and then they use some force plates and all those things, like, to improve the performance of the sports person. Okay, so yeah, so with this, maybe I'll stop here. What Hari, we'll close this. Maybe in the next session, what we will have, will, as I said, like, so this is all about muscles. If you take muscles, you can find the fundamental unit is motor unit, Again, further we have muscle fibers, small fibers, and we have seen that we have two different types of motor units: fast twitch, slow twitch. Fast twitch is responsible for generating large force in short time. Slow twitch generates low force for longer time. Okay, and now I mean we will see, like, how we act, how we record the activity of muscles. Okay, in the next class, and what are all, for example, I mean this one of the potential application of EMG is even now we have that product, I mean this thing, I mean product by Ottoberg. Okay, they have used EMG for controlling prosthetic hand, okay, upper limb processes. We have that in market. It uses EMG for, like, this thing, I mean controlling the prosthetic hand. And yeah, so we will see that, maybe, like, we will try to record, I mean we will see, first of all I want you to see how the EMG appears. Okay, whenever we say signal, by the way, what are the important parameters of signal? If we take signals, what are all we will be interested? What you will see? Amplitude, time, then frequency, yeah, then amplitude, okay, frequency, okay, then another one parameter is that phase. These three things are very, very important. Okay, of course signal means with respect to time only in our context. Okay, okay, don't blame me. Okay, okay, so uh, I mean we will see first of all how EMG looks like. Okay, then we will see how do we process it. Okay, you got my point. Tomorrow maybe we also explore, like, how the sensor works and other things. But I mean this is too early to discuss about that. We will show some sensors, and then, like, we will explore about the working on tomorrow. Okay, this is the plan. Okay, I'll stop here. Uh, we will again, like, maybe we will have a short this thing break. Then again we will assemble and we will I mean, like, discuss about the signal recording and other things. Okay, yeah, thanks. Disorders. Okay, if you see, what we can maximum do is we can just manage the symptoms. We have medications. Okay, uh, and I mean with that we'll make sure that, I mean we means in the sense doctors, researchers, scientists, make sure that patients, I mean the symptoms will be reduced. That's it. Okay, but apart from that, you cannot completely get rid of the disease. Okay, because, like, I mean most of the time we don't know why this happens. Okay, for example Parkinson's, we don't know why it happens. Okay, I mean sometimes doctors says that, like, it is genetic. Genetic means, like, there should be some starting point, right? No, again, like, I mean what is the reason for the starting point is another big question. So this is all about brain. Okay, so what we have seen, brain controls muscles. Muscles, if you look at a narrow level, what we have seen, muscles made up of motor units, small motors. Okay, we have seen motors, right? No, in I mean vehicles. Okay, we have, okay, I mean if you see, I mean again, like, I mean I'm not a what an expert to discuss about motors, but anyway, if you see, like, muscles, you can think of think of, like, we have many small motors, and it will be integrated and, like, help us in performing most of the activities. So motor units, again, if you look at closely, its motor units, I mean contains several muscle fibers. Okay, and we have discussed about motor neuron, if I'm correct. Motor neuron is connected to muscle fibers, and this motor neuron is, like, what, like, basically, like, I mean the brain passes the information to muscle through motor neuron. So these are, like, some of the basic physiology. uh, I mean, like, I mean we want you to be aware of to start this course. Okay, then, like, we have also discussed about two different types. I mean we discussed that there are two different types of motor units: slow twitch muscle fibers, fast twitch muscle fibers. For example, fast twitch athletes. Athletes, like, if you see, most of the time their training will be tend to such that they will target their fast twitch muscle fibers, in the sense, like, more fast twitch muscle fibers, more force in a short time. Okay. And if you take any muscle, okay, for example, let's say our biceps muscle, 50% of fibers are, like, slow twitch, 50% are fast twitch. But if you take our limb muscles, lower limb, thigh muscle, most of the fibers, let's say majority of the muscle fibers are slow twitch muscle fibers, because, like, it should go, we, for example, like, we are standing for a long time, like, so that's one of the function of slow twitch. You cannot run for a long time, right? No, after a certain time, like, we'll be fatigued, we'll be tired, fatigued, and so on, right? No, so most of the muscle fibers are this thing, slow twitch muscle fiber. So these are, like, some of the classifications. Now, in this session we will discuss about okay, how do we measure the muscle activities? Okay, how do we measure the muscle activities? What are the different types of sensors we use? Okay, and we will discuss about the ways and means of measurements. Okay, so these three things, okay, we will be going to study. See in this class. Is it coming? Okay. Yeah, it's not coming. Huh? It's not. So yeah. By the way, if you have any doubts, you can ask me. Like, we will help you. Any doubts related to, so far we discussed, right? Some of the fundas, and we have also discussed about neurons. Okay, if you take neuron, we have a head part and tail part. Head contains dendrites, and then soma, cell body, then axon, then synapses. Okay, all those things. Through synapses, like, it connects with other neurons. Okay, so this is all, like, some of the basics. என்னாச்சு என்னாச்சு ஓகே, அதர்வைஸ் நான் என்ன பண்ணலாம்னா, தம்பி உங்களுக்கு ரெடியா? ரெடியா உங்களுக்கு? Okay, fine. So yeah, how many of you heard about electrode? Electrode. I think mostly everybody, you would have studied in your 12th class, right? No, chemistry, right? No. So what is the function of electrode? Hmm? Sorry, ma? Sense the biosignals. How? How? See here, the issue is, see why. This topic is, like, very much. We are very much interested. For example, if you see, we are talking about muscle. Okay, muscle. For example, we'll consider biceps. The muscle is inside. right? No, this is my biceps, muscle is inside. I'm going to place, I mean, I'm going to place electrode on the muscle, right? No, so inside we have body fluids, right? No, blood, muscle tissue, and whatever we have discussed, what are it? Muscle fibers, all are inside the body. Outside, what we are going to place? Electrode. So, I mean, if you see, generally, uh, this electrode will be connected to some system, okay, and what we measure is voltage, right? No, so how this conversion happens? See, inside we have body fluids, right? No, cells, tissues, all those things. Outside we have, what? Electrons. Okay, flow of electron is current, right? No, so how this conversion is happening? Any idea about it? Yeah. So ionic potential. See, in our cell body, okay, this is very, very important, this thing. Okay, so if you if you if you consider this thing, in our case, biceps brachia, any cell, muscle cell, okay, uh, there are there are different ions. Particularly if you see, we will have sodium ions, Na plus, we will say, potassium, and what else? Chloride. Great, right? No, so we have these three ions, right? No, so now when we place electrode on the, let's say, skin, what happens? What could be the this thing? Possibility. What? Yes. Sorry. Mm-hmm. See, inside we have body fluids. In terms of ions. Outside, what you have is signal conditioning circuit or your system. Okay. Generally, some current will be flowing, and what you'll be measuring is some potential change. Right now. So, the moment we place electrode on the source, okay, it has to convert, right? No, some of this body fluids, okay, or let's say change in the concentration of the body fluids should be detected by the electrode, right? No, so here uh, again, now I'll come back to the question. Okay, so what is the principle of working principle of electrode? Electrode is, you would have studied, right? No, have you heard about Nernst equation, right? No, so Nernst equation, if you see, uh, I mean it's a relationship between ionic potential and what your electric potential. Okay, ionic potential to electric potential. Okay, generally, you would have studied, minus RT by N F ln C out plus, concentration of ions that are, let's say, outside the medium to inside the medium. Okay, so similarly here, what actually we do, we have different ions in our body. Okay, the moment when the electrode, when we when we place the electrode on the source, okay, some kind of what, like, action will take place. There are, yeah, oh great, okay, fine. uh so yeah, I was explaining the electrodes. This is not occurred, by the way. இதாகல ஆகல. It's not next slide. Okay, I'll come to this. So I'll just know, by the way, just know, give a brief about working of electrodes. See what happens the moment, see, electrode is a metal actually. Okay, whenever the metal, okay, comes and having a contact with the body fluids, okay, some sort of reaction takes place. Okay, what are all the reactions? You would have studied reduction and oxidation. Okay, reduction and oxidation. Okay. So I mean, this generally what what happens if you look at a narrow level? Inside the body, ions will be moving. Outside the body, okay, proportionally the electrons will be moving. So whenever, okay, there is a flow of electrons, what it results in? Current, right? No, right? No. So this is the, this thing. This is how, like, we capture the biopotentials. Okay, it is not only for EMG, sorry, muscle. The same principle is applied for ECG. If you place your electrode on chest, or if you place the electrode on scalp. Okay, got my point. So, but I mean, it's good, right? No, for example, like, you have some metal, you are placing on the body, and you are connecting that electrode or metal, whatever, okay, to your system, and get some information about the underlying organ or tissue what you are interested in knowing about it. Okay, for example, uh, if let's say if patients are lucky enough, with ECG itself we can able to predict the heart issues well in advance. Okay, so that's pretty this thing. Okay, ECG, if you see, yeah, and in fact, like, brain related symptoms also you can get it. Similarly, here we have muscle, and if you place electrode on muscle, you will get electrical signal of muscle, which is nothing but electromyography. Okay, so electromyography is nothing but it's a electrical activity of contracting skeletal muscle. We use a sensor called electrode. So when we say sensor, I think you might have studied, like, you know about what is sensor and what is transducer and so on. See, this electrode act as a transducer, and it converts the ionic potential inside the body fluids. You have sodium and potassium, Na plus, Cl minus. Generally, like, if you taste your blood, okay, it will be salty, because, like, you have more sodium and potassium. So the moment if we bring electrode, and like, if the electrode, let's say, are contacting the source, then, like, some potential fluctuations is there. Okay, so this is a rough idea about this. So here, yeah, so surface EMG is nothing but electrical activity of contracting skeletal muscles, number one, and that can be recorded with the help of sensor called electrode. So this electrode converts ionic potentials to electric potentials. Okay, this is again, and one thing, like, this again, the same principle is also applicable for the ECG also, the same thing, like, EEG also same thing. But anyway, let me not worry about all those things. It's fine, right? No? So
good morning. How many of them haven't filled up this form, introductory form? So you can raise the hands so that so please fill in, because already we have segregated a group. So based on that, we have to segregate. So please send your.
okay, it's fine, right? No? Record where I took my work. Okay, yeah, just no, we'll complete this session, by the way. See, you can see, I have brief about everything whatever I discussed so far. Okay, so surface EMG, it is a technique for evaluating, recording, okay, the electrical activity of muscular system. Okay, and we have seen that muscular system is responsible for generation of force, and responsible for maintaining movement, and responsible for, like, having verbal communication. Okay, and we have also seen the muscles are made up of motor unit, and each motor unit, okay, contains single alpha motor neuron, alpha motor neuron. In fact, we have seen right now motor neuron. It starts somewhere from motor cortex, and it just it comes down, okay, and ends at spinal cord, and spinal cord, from spinal cord we are going to have alpha motor neuron, and that actually connected to muscle fiber. We have seen that this as well, and we have seen that CNS, central nervous system. I haven't used the word central nervous system so far. Central nervous system is nothing but like brain, spinal cord together. We say central nervous system, and we also have peripheral nervous system. Okay, apart from CNS, we have PNS, and yeah, so and so on. So yeah, so this is CNS. It just gives stimuli, okay, to alpha motor neuron to generate force, okay, and we have seen two things: slow twitch muscle fibers and fast twitch muscle fibers, okay, and you can see this. Uh, See, this is generally like this symbol, okay, represents uh, the head of the neuron. Okay, if you refer any classical neuroscience book, any classical neurophysiology book, you can find this kind of symbol. Okay, so this is the head of neuron, and you can see this the neuron, like see, it's just an end in muscle, which means like this is motor neuron, okay, and you can see this is what like uh, motor, this is one motor unit, okay, and these are a group of motor units. Again, if you look at motor unit, again you have a lot of muscle fibers, okay. Next, ma. Now, so we somehow have idea about EMG, okay, electromyography. What are the different types? See, generally, like these are all two. There are two types. Okay, needle EMG, needle electrode based EMG, and surface electrode based EMG. But again, these are all conventional techniques. Now, okay, we have also, have few more techniques that like based on since like you all would have aware about this thing right now, about the tech. What like the developments, recent developments in the electronics and then technology, like made researchers to come up with the different attempts in sensing EMG, sensing muscle activity. So it added some of the few more techniques, but broadly, like there are two different techniques: needle EMG, surface EMG. You can see from the figure itself. See, needle EMG. You can see this. This is a needle. Okay, they insert this into the skin, and then they record the electrical activity of muscle. Okay, so which means this cannot be performed by you and me. Okay, this can be performed only by doctors. Okay, certified doctors only can do this. Okay, and again, uh, see this thing. Okay, see, this is what I'm saying. See, this is electrode. Okay, this is electrode. This is electrode. Okay, anyway, we will be showing this now to you. Uh, I mean, here this technique, it looks pretty simple. Okay, we are going to place the electrode on muscle, and we collect some data, signal, surface EMG in our case. Okay, so yeah, this fine. Now, see, this we cannot, perform. Okay, needle EMG we cannot perform. Surface EMG, you and me can perform, right? No, it's fine. Now, you, you tell me, okay, in terms of quality, which technique would be better, needle or surface? Needle. In terms of, let's say, let me just know. Uh, discuss based on diagnostic and prognostic aspect. Let's say diagnostic aspect first. Which one is best? Needle. Why? No, think in terms of engineering point of view, please. signal will be more accurate. Why? Directly mechanized. Yeah, great. Yeah, great. Yeah, this is what impedance. Impedance will, yeah, impedance will be less. So impedance will be less. SNR, I mean noise will be less, more localized. Great. Yeah, you get precise signal. Okay, you get precise signal. Okay, I mean precise in the sense will not have much noise. SNR will be good, right? No, which means, I mean, based on that signal, we can take decision. Okay, but now, if you see in the previous session, I was just telling like recently we have one I mean what like EMG based company called Otterbeck. Okay, I think I don't know whether I named this company name. Uh, we have yeah, upper limb processes. Okay, I mean upper limb process in the sense, I mean for those who lost their hand. Okay, they came up with EMG controlled prosthetic hand. Okay, so which means EMG controlled prosthetic. EMG, based on the EMG, this prosthetic hand will function. That's it. Okay. So now if see, needle EMG is good, right? No, but if you see for applications like, as I said, like processes, and for application, let's say I want to measure or monitor the performance of a sports person. For that, like can we use needle EMG? No. I mean, again, processes. I mean, for example, like if you want to collect some signal from the muscle and you want to activate, I mean, you want to control the processes based on the signal. In that case, can we use needle EMG? You cannot do it. And if you want to, let's say, measure whether the muscle is fatigued or not, uh, can we use this? For example, like I want to see whether I'm maintaining the posture. Whether I'm maintaining the proper posture or not. Can we use needle EMG? Because we cannot use. Why we cannot use? Because I mean, if you want to do that, because for example, these are all like performed by doctors, and for for example, this cannot be, I mean, we cannot continuously place the sensor on muscle and we will ask you to perform activity. I cannot, for example, I cannot like put needle on your let's say thigh, and I cannot ask you to run. You get pain, right? No. And I cannot ask you to, okay, now you go and like do all your work. I'll see how your muscle performs and so on. You cannot do it, right? No. So that's one of the main reason, like and in fact another one, this thing is, by the way, in that case EMG, I mean engineers cannot work. Okay, for example EEG, if you see EEG, it's a clinical modality. Okay, which means from EEG doctors can conclude the state of the brain, right? No, EMG is not a clinical modality. Okay, needle EMG they use up to some extent. There are some, for example, like nerve conduction study. Okay, I think they use needle EMG and so on. But the clinical utility of EMG is very low, or like it's coming up. Many are working. DK, DK. I mean, Dineskant, our professor, he has been working in this field for about 30 years. That I think he said that some 31 years he is working in this field. Okay, so I mean that's fine. So now we will come to surface EMG. Yeah, here you tell. Just you tell us what are the drawbacks in surface EMG. ECG interruption. Yeah, great. Then the same thing. Noise you will get because you are going to place electrode outside the body, right? No, so the muscle is there inside. Outside, like we have skin, right? No, some signals will be attenuated when it what like when the signal propagates from muscle to your sensor, right? No, some signal will be lost. Then what else we can say? And let's say I am attaching sensor, okay, and I am asking, I am interested in monitoring the performance, okay, in sports person, and I'm giving I just know I train them. Okay, after some training, now I'm asking this thing. I mean, asking to, let's say, do some running and I'm seeing the EMG, then in that case, what happens? Like, when we run, I mean, when the sensor move, I mean, go up and down, move up and down, right? No, those kind of this thing you cannot avoid. You cannot perform. You see when I mean, as far as the surface EMG, needle EMG, generally, like, you cannot perform movements, but basically muscle is what, like, what all the measure what we do to analyze movements. And in surface EMG, we have been asked to, you can do movement. I mean, sorry, you can perform movements, but when you move, the sensor also just moves up and down. That also contribute to some noise. So what we call it as movement artifacts. Okay, so that also adds. That's a big headache for us. Okay, and ECG another headache. Okay, and I mean, as I said, like, source. For example, like, I'll tell you. I mean, if you take our forearm itself, we have about 15 எவ்வளவு muscles pa 15 muscles. How many muscles there in 4? 6. Okay, so see 10 plus muscles are there in our forearm itself. Okay, now when I place my electrodes, I mean, then, like, again it will be difficult for me to see which muscle is contributed the EMG what we have recorded. That's another research problem. Despite all these challenges, all these difficulties, you can see a lot of research group, okay, working in processes, in movement science, in sports mechanics, and in ergonomics, in rehabilitation. Okay, I mean, again, the question is how they come up with their own measurement strategies. For example, they design I mean, their own high density EMG and so on. That's on, and they come up with, like, I mean, novel signal processing algorithm, some decision making, classification, AI, and so on. Okay, so this is all about this thing. See, again, one important difference is, since the electrode will be, I mean, since the electrode have direct contact on muscle, okay, the frequency, what I mean, if you look at the frequency of the signal, like, it will be, I mean, if you see, like, you can see up to 200 kilohertz. Okay, whereas in surface electrodes, if you measure, I mean, with surface electrodes, if you measure EMG, you can see only up to 500 hertz. Most of the signal will be lost. What, like, lost in the this thing. I mean, what the layers. For example, we have. I mean, if you see between skin, between the electrode and the muscle. Okay, we have fat layers. We have skin layers. Okay, so the electrode will be lost. Okay, when, I mean, during its propagation. Okay, so this is what. And yeah, as I said, next slide, please. Yeah, as I said, see, this is what I said right now. See, I mean, this is surface electrodes, conventional electrodes, which we are going to, I mean, show. I mean, which we are going to, I mean, like, we have electrodes and we have our system. We have Delsis EMG system, and we'll be having demonstration now. I mean, you can see this is the electrode, and this is surface. I mean, surface electrode attached to the muscle. I mean, see, these are all like, I mean, the recent development that are taken place in surface EMG instrumentation design. Okay, you can see these are all electrodes. I mean, surface electrodes. Here, the same surface electrode, but small in diameter. But if you see, you have array of electrodes. Okay, you have small electrodes. You can see this. Okay. Okay, this is what we call as high density surface EMG electrode. As I said right now, we do research, okay, not to enhance the signal quality. Then how do we enhance the signal quality is a question. One way is you can come up with accurate, effective, efficient system such that you will get, I mean, you will have, like, signal with, somehow good SNR than your conventional surface EMG signals. Okay, so you can see this. Okay, this multi array, and now, in fact, like, because of this thing, I mean, now we started talking about wireless EMG signals sensors. Okay, see, this is wireless EMG. In fact, what we have is wireless EMG. Okay, we'll be going to show this. So you can see this. Okay, see, these are all some wireless electrodes placed on EMG. These are all like by the Delsis system, okay, Delsis electrode, and you can see high density EMG, okay, and other things. Now, I mean, now our question is, yes, it's fine, right? No, we have needle EMG, we have surface EMG, we have high density EMG. I mean, whether like, I mean, in terms of information, whether like we are going to have like better information or not, that is another important question. Okay, we have, you can see this next this thing. Yeah, so this is very important observation as far as surface EMG instrumentation system design are concerned. See, when we are interested in movement, okay, for us surface EMG itself sufficient. Okay, you can see this, it provides information about movement. Okay, but as I said, let's say you have multiple muscles, and like very small muscles are like let's say actively contributing to movement, and you want to know which muscle is dominated in that particular movement, then you have to go for high density EMG. Okay, you can see that like if you will get information with respect to muscle, even some extent you will get information with respect to motor units and so on. Okay, and then if you, and needle EMG, as I said, we were discussing about localization. Needle EMG will get information with respect to muscle fiber. We'll come to know about like the this thing. I mean, we'll get an information about muscle fiber at a muscle fiber level. Okay, muscle fiber and a muscle membrane, whatever. Okay, so this is very important. So what we have present, okay, in our lab, we have a conventional surface EMG system, and then identity you have right now, identity surface EMG system. Okay, which means we will come to know about movements, okay, and we will come to know about the muscle, I mean muscles, okay, particularly like group of muscles. As I said, in our face itself, like we have 40 plus muscles. Can you imagine that 40 plus muscles? And if you are interested in knowing about like the involvement, for example speech, we are also like I mean uh, one of our I mean colleague, okay, she's working in facial expression, where like we'll be interested in like recognizing or recognizing the micro expressions, very small minute changes in the face we record, and we try to capture what they are trying, what they are hiding, or what they are thinking, and so on, micro expressions. So that those things can be done with high density surface EMGs. Okay, and another one difficulty in surface EMG, as I said, see, surface EMG is not that good signal, okay, because like it is not localized. Okay, SNR is poor when you compare to needle EMG. And another one difficulty is, if you see ECG, I think those who studied biomedical instrumentation, they may be aware of this. For ECG, there are standards. Okay, we have we call it as different limb leads or something like that, right? No, yeah, Enthovin triangle. Yeah, Enthovin, great. Enthovin triangle. Okay, we have, because like there are standards for electrode placements. Okay, standards for electrode placements. Similarly, EEG also we have standards for electrode placement, 10-20 electrode system. But in EMG we don't have any recommended standards for electrode placement. That is another big headache for us. Okay, for example, I place electrodes, I mean on muscle somewhere, okay, and I collect it and I report it. But somebody in let's say in somewhere, okay, let's say other side of the this thing, okay, here, like he do the same experiment on maybe some other position, and he may report this thing, I mean some different results. Again, now the question about reliability comes into the picture. So we don't have standards. In fact, like I mean there are recently like a group from Europe, like they came together and they started working on standards, what we call it a CNIUM. Next, I think next, yeah, so it's just yeah, CNIUM standards. Okay, so they have prescribed the shape, electrode shape, Okay, for example, different shapes of electrode. I mean, electrode can have different shapes. Okay, it can be square, it can be of square shape, you know, or rectangular. Okay, and so on. Uh, they just know prescribed shape, size. Inter-electrode distance is very important, you know, parameter as far as surface EMG signals are concerned. Okay, inter-electrode distance, electrode material. Okay, sensor construction. Okay, they have given some idea. Okay, and in fact, unfortunately, as I said, we have, I mean, several muscles. Okay, and I mean, this project now again, these people they move to another project. Okay, but they have given some guidelines for you know, some muscles. I mean, for few muscles. Okay, very few muscles, not all the muscles. With this, like, you know, we are working. Can you please move next, previous slide, previous slide, previous slide, previous slide. Yeah, previous slide. Yeah, next. Yeah, this is very important. So this is what I was talking about. You know, you can see this. This is our muscle. Okay, when we place electrodes, okay, you can see when you place, okay, see, I mean, these are all electrodes, by the way. See, I mean, you can see when they place electrodes on ear, okay, they get something like this signal. Okay, what we call it as a neuromuscular junction. Okay, neuromuscular junction in the sense we were discussing about motor neuron and it connects to muscle, and this motor neuron, like, you know, I mean, stimulate this muscle to contract. So that's this thing. So when you place your electrode on motor neuron, you will get something like this. And if you place your electrode here, end of the muscle, you will be getting something like this. And if you place, you can see on middle or on, let's say, right lateral or you know, left lateral, whatever, you will get this. See, from this, what I mean, what we can you know, conclude, if you are placing the electrode on middle of the belly of the muscle, you will get somewhat good signal. Okay, you can see this. See here, for this signal, I mean, for this electrode, you are having very good signal. Okay, if you place here, then, like, no, you will not get, you know, good signal. Okay, this is an experiment. Generally, like, you know, we try to place the electrode on the belly of the muscle. Okay, next, and most of the time, again, like, you know, this you guys may be aware of. What is this? Any idea? By amplifier, operation amplifier. Then you, can you be little precise? What is that? Instrumentation amplifier. Yeah, different. Yeah, great. Differential amplifier. Differential amplifier. Yeah, differential amplifier. Okay. See, yeah, good. See, you can see this. I mean, why just no? I mean, I wanted for this you know, word. Uh, I mean, see here. See, I mean, can you go to previous slide? Yeah, you just know, you look at this figure. Okay, this is one electrode bar. This is another one electrode. We have third electrode. Okay, will be somewhere close to bone. Okay, then you go to the next slide, please. Yeah, here you can see this. Uh, here, see, this is you know, on muscle, belly of the muscle. This is another. This is again close to that. Generally, like, you know, the inter-electrode distance between inter-electrode distance is like, you know, what, like, you know, given as, I mean the inter-electrode distance is just fixed as per the CNM standards. Okay, so most of the time we prefer to have bipolar electrode. Why? Because you can see bipolar in the sense you have two electrodes. Okay, and I mean, we will be, yeah, I mean, we will be interested in what, like, you know, potential difference, like, you know, between, I mean, measuring potential difference, like, you know, between these two electrodes. So in that case, if some noise is there in one electrode, you know, okay, and I mean, we are talking about common mode noise, by the way, and then the same noise is also been recorded in another electrode. Okay, and And if this is a case, then when we use bipolar electrode, then the common mode noise will be removed. If you use unipolar this thing, let's say unipolar connection, in the sense you will be having only one electrode on the belly of the muscle, and another electrode will be maybe on, like, somewhere here, okay, which means the noise will be there in the signal, okay, and, like, so that also affects your measurements. So most of the time we prefer to have bipolar electrode, because, like, the common mode noise will be eliminated. And in fact, the advancement of this version is instrumentation amplifier. Okay, instrumentation amplifier, what we love, I mean, again, there will be too much technical. I mean, about CMRR, common mode rejection ratio, right now. So we'll have better CMRR right now. Yeah, that is also fine. But, like, what I have shown is not an instrumentation amplifier; it's a differential amplifier. Okay, but again, instrumentation amplifier also will work for this purpose. Okay, next. So, yeah, I think next. So these are the characteristics. By the way, I'll stop here. Okay, we'll go for the demonstration of this. So whenever, if you see surface EMG will look like this. Okay, and if you see the amplitude, it will be plus or minus, I think 1.5. I mean, sorry, 10 millivolt. Okay, 10 millivolt. Okay, and if you take Fourier transform, FFT, fast Fourier transform, and the spectrum will be looking like this. Okay, you can see this here again. You can see here. So the frequency range, it will be from 0 to 500 hertz. Okay, and here the dominant, if you see, dominant energy is from 550 to 150 hertz, in the sense, see, most of the energy, okay, if you see, most of the energy will be concentrated only from 50 to 50, you will have somewhere here to 150, okay. Most of the energy will be concentrated from 50 to 150 hertz. And here, one of the very important information is this. Generally, see, we were discussing about slow twitch and fast twitch, right? No, slow twitch, the diameter is small, and, like, it generates low force, right? No, so generally diameter is small, in the sense the conduction velocity will be slow. So conduction velocity is slow means, like, it results in low frequency. Okay, V is equal to d by dt, sorry, d by t. Okay, V. So conduction velocity is slow means slow, yeah, slow, yeah. Conduction velocity is slow means generally, like, the frequency will be low. Conduction velocity is fast means it just the pulse, what, like, is transmitted fast, which means the frequency is, like, high. Okay, so you can see this, the slow twitch, from 75 to 125 hertz frequency band, okay, corresponds to slow twitch motor units, and 125 to 250 hertz frequency band corresponds to fast twitch, motor units. And very importantly, you can see, as I said, fat layer and skin layer greatly attenuates the amplitude and frequency components of the signal. Okay, and here few things, like, in a research perspective, I'll tell. See, now you know about surface EMG, you know how the signals look like. Great. We'll get information about movement, right? No, yeah. So here the issue is, even if you perform same movement, okay. See, I'll repeat. If you perform same movement, okay, and let's say, this is the criteria. You have your sensor. You are keeping your sensor on, let's say, muscle, and you are recording signal. Even you perform same movement, you will not get the same signal. The signal characteristic changes. So that is also another challenge as far as signal processing people are concerned. Okay, why it is changing? differs. Yeah, motor neuron differs. I mean, the firing rate differs, even the movement remains same right now. Yeah. So yeah, so this unreliability, okay, can also be. I mean, if you see, like, several papers, okay, discussed about all these things. In fact, these are all, like, some of the drawbacks of surface EMG. Why? I mean, doctors. If you ask doctors about this signal, they will say this is noise. It's not. You will not get anything about anything about, like, this thing. I mean, like, what, like, the actual information and so on. But despite that, like, there are, like, some, I mean, this thing, I mean, as I said, like, we have upper limb processes, okay. It's just, they use EMG. And nowadays, like, if you see this EMG is, like, what, like, they're just, I mean, they're using for sports mechanics, okay, to monitor the sporting activity and other things, okay. So next. Mm, so yeah, maybe, like, I'll this thing, uh you can see this, the challenges. I didn't talk about muscular structure. I'll think, like, maybe DK will discuss about muscular structure. Okay, I'll just maybe give a brief overview about muscular structure. For example, uh, if you see, okay, the structures of muscle. For example, if you see biceps brachii, okay, very clean. I mean, very simple and easily accessible muscle. Okay, but whereas if you see forearm muscle, like, it will be I mean, like, you cannot pinpoint. Okay, all are, like, what, like, interlinked. Okay, you cannot separate it. Okay, so these are, like, different. In fact, like, the shape, we call it as parallel shape, triangle shape, rectangular shape, and so on. So uh, I mean, muscular structure is multi-layer, means, like, I mean, it is not uniform. Okay, and then yeah, motor unit fiber distribution is not. Yeah, this is another. We were discussing about muscle fibers, right? No, the distribution of muscle fibers is not uniform. Again, that also differs. In fact, like, it just, no, it should be, right. Now, for example, you think about our face muscles. Okay, you cannot expect the distribution of muscle fibers are uniform. Okay, and our eye, this thing, I mean, the eyebrow muscles. Okay, you cannot expect that right now. So again, the firing pattern varies. Yeah, this is what I was telling. Okay, maybe, like, you'll be studying about Honeyman size principle. Okay, we have slow twitch, fast twitch. When the brain activates, how it's going to activate it. For example, like, as I said in the morning, like, we are discussing about our example, right? I mean, we have taken this thing, right? Now, when we try to lift any object, like, I mean, we have different muscles, right? No, different muscles. Each muscle contains different motor units. So how the brain recruits muscles? Generally, brain is not going to recruit muscle directly. Your spinal cord recruits that. But again, how is this happening? And again, what is the kinetics and kinematics of this process? Okay, I mean, kinetics in the sense the direction of movement, right? No, generally you can see that whenever we perform any movement, we will take the shortest route. Okay, you need not have to tell your brain. Okay, it has been trained that how it's happening. So that is all about your kinetics, right? No, kinetics means what? Distance, velocity, acceleration, and so on. Sorry, kinematics. Kinetics is force, right? No, how much force it should generate. I mean, those information will be known, but again, uh, given this many, I mean, given the proportion of motor units, how I mean, the brain, decides which motor unit to use and which motor unit, to stop. That also we don't know. Okay, so those are, like, some of those things. Okay, uh, these are all signal processing. No, these are advanced. Next. Okay, but I'll do one thing. I'll stop here. Maybe, like, we have sensors right now. So with this, so I mean, now you might have known about the electrodes. Okay, Electrode is a transducer that converts ionic potential to electric potential. Inside the body, we have ions. Okay, ions, movement of ions. Okay, this movement of ions is converted to movement of electrons. Okay, by, let's say, the transduction process carried out by the electron. Okay, electrode கொடுங்க. இதுதானா ஒட்டுறதானா? இது இல்லையா? இது என்னது?
இதான் ஸ்டிக்கர், the medical grade sticker. Peel it off.
So what is the inter-electrode distance?
1 centimeter.
இது வந்து இது ஒரு இதா?
ஆமா, இது வந்து ரெஃபரன்ஸ் எலக்ட்ரோட், இது வந்து ரெக்கார்டிங் எலக்ட்ரோட். இதுல